Hello, everyone. This is Elisa Baum. I'm GridGain Systems Director of Product Marketing. I'll begin in just a moment, but first I need to conduct a bit of housekeeping. Could you please raise your hand using the hand icon in the GoToWebinar control panel to let me know if you can hear me? And let me take a look. Okay, can you hear me? Yes, you can hear me. Great. Okay, next, during the session, you will be on mute, but should you have any questions, please go ahead and enter them in the questions field in the GoToWebinar control panel. And at the end of the presentation, we'll take time to answer as many questions as possible and in the time that we have left. And those that aren't will be sent to the speaker and addressed in a follow-up blog post. So with that said, I'd like to thank everyone for attending today's session. It's Take Telecom to the Next Level with in-memory computing, and it's being presented today by Matt Sarrel. Sarrel, sorry about that. And with that said, I'll turn the floor over to Matt. Okay, Matt.
Thank you, Elisa. Oh, by the way, it's Sarrel, but that's okay. So here we are, and we're talking today about. Oops, I have the wrong title, but don't worry, I'll just quickly skip that title. That's it's actually taking telecom to the next level using in-memory computing. Of course, what else would I be talking about? So on our agenda for today, I'm going to run through some introductory materials on telecom and what's changing in telecom and how telecom companies and providers need to leverage different big data and fast data techniques in order to stay competitive. And in order to leverage those to the best of their ability, they'll need to use in-memory computing. So I'll explain what in-memory computing is and what GridGain and Apache Ignite are in brief. And I will share then some survey information about how customers are using GridGain and Apache Ignite, as well as some use cases and case studies for using GridGain and Apache Ignite in the telecom space. And after that, I will go into some information about GridGain and Apache Ignite in depth. So here I am. There's my beautiful smiling face for everyone at home. Who am I? I am an industry consultant, journalist. I've written for PC Mag, eWeek, InfoWorld, all that kind of stuff. Market analyst. I've written for GigaOM Pro and GigaOM Research, and I've been doing this for about 30 years with a focus on networking, big data, analytics, and security. And in particular, the focus on big data and analytics is what will come to play here in telecom. So telecom is basically an industry in transition. There are well over 1 billion smartphones sold globally per year, and many people across the world report that those smartphones are in fact their primary computing platform. And as a result of this, we're seeing less reliance on voice, right? So telecom isn't about voice as much as it is now about data. 50% decline in mobile voice minutes used between 2005 and 2012. I couldn't find a more recent stat, but I would imagine that this has just continued to decline. And also customers are focused on streaming. You can see media and video was less than 10% of all traffic in 2010, and it's almost 50% of traffic in 2015. So that's a huge difference. Declining voice, increasing multimedia, music, photos, and video. So telecom is now all about data. Well, it's not all about data, it's mostly about data. And we see the market is shifting to figure out how best to charge for data plans, how to adjust plans to reflect this difference between voice usage and data usage. tiered usage-based pricing on mobile data, as well as data sharing for households and businesses, like this data pooling idea. And also another thing that's taking place in telecom, especially with mobile carriers, is IoT. So according to Gartner, we're looking at 26 billion connected devices by 2020, which is kind of staggering if you then start to think about the number of connections that are required. So we're looking at consumer and business devices, which will be using, they'll be using fixed access methods like broadband, but there'll also be considerable numbers of IoT devices using mobile networks. Talking about a billion machine-to-machine connections via mobile networks predicted by 2020, which would be 10% of total mobile connections. And I call this out because this is a data connection, not a voice connection. Network operators are also under pressure. There are a lot of over-the-top or OTT content providers, and these are providing new services. And these services challenge operators, and they challenge operators in terms of what an operator can provide and then sell. So, you've got stuff like instant messaging apps now, whereas providers were charging for like text packages and then all kinds of services on top of whatever this text app is. Now you've got like other companies like WhatsApp and Snapchat and even Instagram, stuff like anything, Facebook Messenger, and this is taking away from people using the applications developed by the telecom providers, and in doing so, it's disrupting the value chain, and it's shifting the revenue away from telecom providers and towards application developers. So how can telecom providers adapt? They need to avoid commoditization, right? So if a telecom provider is just like a network, then that's a commodity, and people, have one problem with the network and they leave. But if they were sort of locked in and pleased with other digital services, then they would probably be more likely to stay. But on the other hand, what are the things that telecom providers are good at? And a lot of that is providing applications and providing a fast and reliable network. So the point is to leverage traditional competencies while developing new competencies. And in order to do this, telecom providers need to adopt a data-driven approach in order to stay competitive. So this will revolve around customer experience management, which involves constantly assessing network performance and customer experience, building differentiators like apps or web portals that can build a deep relationship with the customer, and then rapidly capturing and acting on customer feedback in order to provide the best experience possible. There's also, they can distinguish themselves through service levels and personalization, with a high quality, seamless omni-channel interactions with customers, also with this expectation that customers will feel no carrier loyalty and will be willing to switch quickly. And I think that we've seen that. And so personalized service and support interactions will lead towards happier customers and greater customer retention. And again, network quality is, right, this is a core competency. Network quality is a commodity, but if you don't have it, then you're really not going to be able to sell the services on top of it, which is what telecom needs to do in order to be profitable. So right now, operators are going through 4G infilling to provide better coverage and modernizing the backhaul network, as well as preparing for 5G and installing more sophisticated traffic monitoring and performance management. And now, what's kind of interesting is that as I go through this presentation, I will get to the use cases, and I have selected use cases that line up with customer experience management. We have one that shows how to build a better web portal for your customers, and also a network quality management and monitoring solution, as well as another solution which was built to send disappearing text messages. So we get to the good in-memory stuff. So you can see now Telecom highlights a lot of these forces that are driving companies to in-memory computing, right? So customers require real-time interactions and companies require real-time insights. And this is consistent with what I talked about with Telecom. So you've got, traffic is growing, data is growing, IoT is generating a lot of data. These are all things we discussed. And the price of memory is coming down. So you can see on the left, I love these two charts, right? So the amount of data that we're dealing with globally is just, exploding. And at the same time, the price of memory is coming down about 30% every year. So, so this, the need is growing, and the cost to put data in memory is coming down. So that leads us to the growing in-memory technology market. This is from a Gartner study. Basically, this breaks everything out. We're looking at a cumulative annual growth rate of over 20% in these in-memory computing fields. And in-memory computing can get carved up into a bunch of different things, like in-memory app servers, messaging infrastructures, event stream processing, in-memory data grids. But one thing that's important is to actually look for a solution that can provide all of these things, which would be an in-memory computing platform. And this is, in fact, what GridGain and Ignite are. So an in-memory computing platform combines a lot of these other products that I mentioned in the previous slide. We have an in-memory data grid, in-memory database, streaming analytics. There's no need to rewrite all your code and replace your application. Also, the ability to support online transaction processing and online analytics processing as well. ACID compliant transactions, SQL-based analytics support, and what else do we have? We have easy to integrate with other platforms like the relational database or NoSQL, whatever the back end is, and then a unified API. I actually have a diagram which sums this up better, which comes a little bit later. But basically, you get the idea that an in-memory computing platform is a comprehensive solution instead of just a single point solution like a cache. So an in-memory computing platform, it's a high-performance distributed platform, which includes data grid, the memory-centric database, meaning that it uses memory first and persistent storage second. The ability to do streaming analytics, ACID compliant transactions, and full ANSI SQL 99 support for DDL and DML. And to do this, it's built upon an architecture which includes advanced clustering of a distributed key value store, as well as a compute grid and the service grid. And so here's this diagram that I was talking about before. So if you look over on the right, you would typically have your application layer, and then you have your data layer, and your application writes to and reads from the database. And so at some point, stuff's, the business grows and scale increases and performance starts to decrease. So you can slide the in-memory computing layer in between these two and use the connections to the data layer to connect to the data layer, and use the unified API to connect to your application. And in doing this, you get the persistent store with the transactional SQL database in a memory-centric distributed computing environment. GridGain is built on Apache Ignite, and so what we're looking at is in 2007, the company wrote the first version of GridGain. In 2014, and there was a community edition. In 2014, GridGain contributed Ignite, which was the GridGain community edition, to the Apache Software Foundation. It's now the second fastest project to graduate after Spark. There are over 60 contributors, and it's rapidly growing, and it's a mature code base. This isn't some fly-by-night free software. This is a real thing. There are a lot of people using it and a lot of people writing for it. And just to give you an idea of this explosive growth, hey, the only thing growing faster than the number of Apache Ignite and GridGain downloads is the amount of data in the world. Should overlay these two charts. Okay, so if you want to know the difference between GridGain and Apache Ignite, actually, you know what? I have a lot of slides, so I'm not going to just read each slide to everyone. These will be in the, afterwards, Elisa will send a link so you can download the slides, and this will be in those slides. But here's where the differences are. So basically, you can see the differences between Apache Ignite, GridGain Professional Edition, Enterprise Edition, and Ultimate Edition. So essentially, you get better security, faster maintenance releases, and then from there, monitoring GUI, even better security, network segmentation, protection, rolling updates. That's a big thing for people using GridGain in production, data center replication for high availability, and cluster snapshots is added in Ultimate Edition. And that's also a critical feature for people who need to make backups of their production data when they're using in-memory computing as a system of record. Okay, so I talked about Telecom, I talked about in-memory computing, I talked about a little tease about GridGain and Ignite. And so here are a bunch of things that you can use GridGain's in-memory computing platform for, right? Let's see, what applies to Telecom? Well, web session clustering, distributed caching, and scalable SaaS are great features for building customer support and customer service portals. Compute Grid would be something that would be leveraged during like customer analysis, big data analysis. Even to a certain degree, you could leverage Compute Grid in a network monitoring capability to run all the analytics on the data that you're collecting. Distributed SQL is a huge differentiator for the GridGain platform. This is something that's not really offered by very many other in-memory computing platforms. And this gives you the ability to run real-time analytics and do distributed SQL processing. Let's see, streaming data. I have one of my use cases discusses using streaming data for real-time analytics. Hadoop acceleration, in case you want to look at your real-time data in comparison to historical data, and then complex event processing and an event-driven design. GridGain has a lot of customers, big in financial services, software, fintech, logistics and transportation, e-commerce and retail, ad tech, IoT, pharma and healthcare, and in particular in telecom and mobile, we have Huawei, Cyberdust, RingCentral, and Intelligent Pipe, as well as others. So one thing that GridGain did was they sent out a survey and they asked what people are using the platform for. And far and away, the leader here was database caching, right? This idea of reading and writing to disk takes time. Reading and writing to memory is about 1,000 to 10,000 times faster, depending on what you're doing. And so database caching and application scaling, high-speed transactions, real-time streaming lead the uses for in-memory computing. Customers run GridGain in their private cloud, on-premise, on AWS, or on Azure. And which of the following protocols do you use to access your data? So Java, SQL, MapReduce, .NET are the leaders. Java is far and away the big leader there. And which data stores are you likely to use? MongoDB, HDFS, Oracle, MySQL, PostgreSQL, Cassandra, and SQL Server. So we're seeing a lot of SQL there, and NoSQL as well, and Hadoop. And how important are these features, right? Data grid, of course, if you're doing database acceleration, data grid is going to be important to you. Compute grid, in-memory file system, service grid, ANSI SQL 99 compliance, and then it goes down. It goes down from there. Okay, so here we are at the meat of the presentation here. Looking at this, I have 3 case studies, and the first one is of Intelligent Pipe. So Intelligent Pipe is a big data software company with telecommunications customers all over the world. And what they do is they develop solutions for mobile app operators to improve their business and operational processes. So this involves network monitoring and an app that runs on people's phones. So the challenge is to, this obviously, right, it's telecom usage data. So there's a lot of data, huge amounts of data that has to be analyzed in real time, tens of millions of users across the world. They need to be efficient with network resources. There's no point in degrading network performance to manage the network. And they also need to understand the type of network traffic that's being sent. Is it voice or is it data? So Intelligent Pipe used the GridGain Professional Edition to build a high performance, low latency analysis platform. We have this great quote: GridGain ensures responsiveness regardless of how much information we need to search through, from the CTO of Intelligent Pipe, and they collect and analyze multiple terabytes of data per day across multiple providers. And real-time analytics provides fast insight so that then telecom providers can then take action in order to provide this better customer experience, like I was talking about earlier. They were able to easily integrate this new real-time analytics platform because they used GridGain's unified API to connect to applications, and ANSI SQL 99 support to leverage existing business logic that was written in SQL, as well as to connect to backend databases. And over time, they discovered that they were able to scale linearly across server clusters so that they could keep up with the increasing volume of data as the business was growing. And I love this quote because I think this sort of sums up the point of everything, right? We'll want to use technology GridGain offers so we can focus on our core business ourselves. So, you know, I like a quote like this because it shows that the GridGain customers are able to meet their technology needs using GridGain and then focus on the business rather than the technology that drives the business. And they can focus on improving their business and their offering rather than focusing on like tweaking performance and things like that because GridGain's taking care of it for them. So we have another customer who's was able to build a single customer view. So we're talking about they have a portal for customers to use for service and support, and then they run some sort of on-the-fly analytics and personalization for those customers, and at the same time they're running on-the-fly real-time analytics for support and customer service reps. This is a multinational provider with over 250 million customers across mobile, fixed line, and broadband. So this is voice and data. They've noticed that their customer interactions have been increasing online. Not, you know, people are more likely to call them, or actually, sorry, people are less likely to call them for support than they are to go online and try and conduct some kind of self-service for support and billing and service changes. And so they wanted to provide a 360-degree view of that customer for both the customer, they could see all their services and accounts and devices, as well as for service and support. So the requirements were to accommodate increasing traffic. They needed real-time updates to the customer account. So this is like if there was a billing adjustment, I forget what the actual requirement was, but it was like if there was a billing adjustment, it needed to show up in the web portal within 5 seconds or something like that. Or if a support case was resolved, same thing, needs to show up in the support portal. They wanted to increase their query throughput, which is linked to, they had a lot of business intelligence written in SQL that they wanted to leverage. So they wanted to leverage their existing SQL and run it faster. They wanted to future-proof growth in their customer base, so give them the ability to expand to meet demand, so they can continue to perform at scale, both in terms of the customer experience and the employee experience who's serving the customer in real time. And they also had, because they're a telecom provider, high availability and system recovery requirements. So GridGain's solutions architects worked closely with the company to build a proof of concept over 5 to 6 weeks. They deployed it on 10 physical nodes. You could see they're like reasonable machines, but they're not like crazy powerful. You know, this is not an insane amount of hardware. This is like a fairly reasonable amount of hardware, I would think. This would be nothing to a telecommunications company, and yet they've ended up with this partitioned grid topology where they took their existing databases and they stored them all on their own caches across the GridGain in-memory data grid. They received updates from the existing application via Kafka streaming. They then ran distributed SQL queries to regenerate and update customer billing and account details into the in-memory data grid using GridGain, and they used SQL queries to respond to user requests via the customer web portal. So they were able to leverage a lot of their existing SQL code. They built a platform that provides up to 60,000 updates per second, and that was in testing. So they're not seeing 60,000 updates a second in the real world. That's just in benchmarking the application. And which is not to say that the platform wouldn't do it. It's more to say they can benchmark at a greater load than what they actually need right now, which helps to lead to their requirement to sort of future-proof their solution. So individual updates to records complete in an average time of 40 milliseconds, which is pretty amazing. The full customer web view processes within 40 milliseconds, which gets the full web page. So this is when the customer opens the customer portal. They can see their full 360-degree view, accounts, billing, device management, support calls, service utilization, all of that in under 2 seconds, which I think is, dealing with my provider, I think that seeing a web portal load in under 2 seconds would be a welcome change. And they were able to retain all their existing SQL queries and business logic with very little refactoring. So they pretty much got what they needed and what will carry them forward into the future. And looking at our last case study, a GridGain customer is called Cyberdust. They're a platform for text messages. They're billed as a safer place to text. This is a Mark Cuban funded company. The texts are untraceable, encrypted, disappearing, and the app blocks screenshots. And this app is available for Android and iOS. And so the challenge here was to build a real-time, reliable, and highly available server infrastructure to support this mobile messaging platform. Cyberdust has over 500,000 users and processes millions of messages per day. And now actually, as it turned out, one of their goals was to never write the messages to disk because they're promising that they're disappearing. So what better way to never write to disk than to develop in memory? They used GridGain Professional Edition to build this messaging platform. It runs completely on Amazon EC2. This is a whole company running completely on Amazon EC2 on GridGain Professional Edition. All user account data, configurations, and messages are held in memory. Like I mentioned, messages are deleted without a trace because they were never written to disk. And the company, Cyberdust, makes extensive use of the unified API in order to interoperate with other systems. Now, this is kind of a cool thing to think about performance. So there's a blast feature. Actually, legend has it that this was insisted upon by Mark Cuban because he wanted to be able to do something like, say, okay, tell all of my contacts that if they are in a certain place at a certain time, they get a free t-shirt. And so that would require sending out disappearing messages to, well, however many contacts you had very quickly. And so as part of their POC, they benchmarked 300,000 messages sent and disappeared within 30 seconds, which seems pretty cool to me. And again, 2 great quotes. Of course, I love the quotes. surprised by GridGain's solution and performance, additional capabilities that GridGain offers. It's more. It's what I expected and more from the CTO. So what he expected and more. So let's run through now looking at the GridGain in-memory computing platform in depth. So this is like looking at the unified API, all the languages that the API supports, the in-memory data grid, in-memory database, streaming analytics support. It's all backed by a persistent store, which enables memory-centric computing, and their support for SQL, full ANSI SQL 99 with ACID compliant transactions. It's built on the open source Apache Ignite technology. And because no rip and replace is necessary, this then becomes the least disruptive approach to in-memory computing in order to provide speed and scale to existing installations. Let's look a little bit deeper. There's a transactional SQL database in memory backed by a persistent store. Now, what GridGain will do is use the data that is stored in memory first for greater performance, and then involve the data that's stored on disk in order, to provide a more thorough answer to queries if necessary. And it's really easy to install GridGain. I would encourage you, if you're interested in anything that I've said, to go to Ignite, Apache Ignite page, and download the installation program. And it installs, like, I actually, in order to learn stuff to give, so I knew what I was talking about, because I'm a hands-on person, I downloaded it and installed it just on my laptop. And that, that's not a production environment, but it gives you a chance to run Apache Ignite and learn more about what it does and what it can do. And what code you've written that'll run on it. And then you can move it later to commodity hardware, server environment, and scale up vertically, or horizontally. So let's see. So the promise of all of this is to move towards, like we saw with that middle case study, to move towards combined transactions and analytics on a single platform, instead of the traditional, like, do your transactions in one platform and then ETL everything over to another platform for analytics. We now have a platform that is fast enough and interoperable enough to run high volume transactions as well as big data analytics in memory. So that in-memory data grid, which I've talked about, basically this is a distributed key value store. And this is basically like the core functionality of GridGain and Apache Ignite, to take the data from your existing disk-based database and put it into RAM. You get better scalability, better performance, distributed in-memory transactions, and then you can work on the data that's in the data grid using the in-memory compute grid, which is basically parallel processing of resource-intensive tasks, compute-heavy tasks across the cluster. GridGain actually takes care of a lot of the intimate details automatically, with automatic load balancing and fault tolerance, and you can very easily schedule and checkpoint your jobs. So distributed SQL is a huge product differentiator for GridGain and Ignite. Most in-memory computing platforms do not support SQL, and if they do, they do not support full ANSI SQL 99. GridGain has support for all DDL and DML commands. And then actually what's also cool is that the SQL runs distributed, which speeds it up over like running through one central SQL interpreter. And then there's in-memory streaming analytics, which allows queries into sliding windows of incoming data. And I'm not kidding you, like to consume a stream is like 2 lines of code. It's very, very easy to do streaming data analytics in GridGain and Ignite. You can customize the workflow, build your windows. GridGain indexes data, builds its SQL indexes on the fly, so you get faster query responses to streaming when you're doing your streaming data analysis. And you can also co-locate the streaming consumption engine onto the nodes. So it's like you can minimize network traffic when writing to the in-memory data grid for greater performance. Brand new in the most recent version of GridGain and Ignite is the persistence store. And this is actually another really great feature for production environments. So now the full data set can be saved onto disk with some of the data set kept in memory for greater performance. And GridGain can run ACID transactions and SQL queries across data that's in memory and on disk. And so this is a memory-centric architecture with memory used to provide greater performance, distributed transactional SQL database, scalable to many, many nodes and across a number of data centers. I believe it's 32, up to 32 data centers. And again, ANSI SQL 99 support across the complete data set, both in memory and on disk. GridGain is also used for Hadoop acceleration. So this provides easy to use extensions to disk-based HDFS and traditional MapReduce, and will give up to 10x faster performance simply by installing GridGain on top of HDFS and working with data in memory, completely migrating from HDFS into GridGain's file system, and then holding data in memory will also give you an even greater performance improvement. And let's see, there's an in-memory service grid, which provides control over GridGain and user-defined services on each node and across the whole cluster. And this gives you a lot of automatically managed capabilities for building a service-oriented architecture using the GridGain in-memory compute platform. And that brings me to the end of my presentation. And I believe that Elisa will now open the floor to questions. And let's see, what do you guys have for me?
Okay, audience, so if you have questions, please go ahead and enter them in the questions field in the GoToWebinar control panel. So the first question has to do with the slides in the presentation. Yes, I will make sure that you get a link to the recording as well as to Matt's slides within 48 hours, probably a lot sooner than that, just whatever processing time it takes. Okay, are there any other questions for Matt? So far there aren't. Just give people a couple seconds to respond. Okay. I think you did a really thorough bang-up job there, Matt, because I don't think there were any questions.
I don't know. I did 45 slides, which is some kind of record, I think.
Yeah, good job. Okay, then. Well, Matt, thank you so much for a great presentation, and audience, we hope to see you on a future show. Thank you for attending. And everyone take care. Thanks again, Matt.
You're welcome. Thank you.